series where in this first video we're going to discuss the tools and techniques of reading a geologic map. Okay, so if you haven't opened up your Lab 9 yet, you probably haven't seen a geologic map before. So this here is a geologic map. Alright, so a geologic map is just a regular topographic map like we've been reading. Alright, and the rock units that are exposed on the surface and where those rock units were found. Alright, so if we look at this, we have this brown, this purple, this pink, purple, pink, and all that. Each one of those represents a different rock unit. Okay? And then what also is on a geologic map is what's called the attitude of a rock unit. So I do not know if you can see that, but there is a little symbol, a little crosshatch, and a number right there. Alright, I'll draw it here. Alright, and this is the attitude. Alright, simply it is its compass direction that it's going off in, its trend or bearing, and how far it's tilted down from horizontal. Okay, so how do we read all that? Well, it helps to understand how that data was collected. Alright, so we have our attitude, which is going to be the precise orientation with respect to a horizontal plane and compass direction, and we measure that with a compass. So here is my beautifully drawn compass with north going that way and east here, southwest. Y'all know how compasses work. Alright, and so what we can do is look at this compass and just envision it as a circle. Now what's special about circles is they have 360 degrees, and from there we can just take the angle from a reference angle to find our bearing. Okay, so our bearing is just going to be, the compass direction of a line. Alright, so I've already drawn a line in here. Alright, so what's going on here is we have, say this is a bedding plane. Alright, so it's going off in this direction. Alright, and from here we can measure and record how far it's going and the angle, alright, and which direction it's going. Alright, so now we do that two different ways. Alright, we can record that in two different ways. Alright, the first one is called quadrant. Okay, so this is going to be our degrees from north or south, and in what direction, east or west, is it going. Okay, so for an example, we have, it's written as north 45 east. So how would we represent north 45 east on our compass? Alright, is we have our north. Alright, so north here is going to tell you it's in the northern hemisphere. Okay, so that covers this part here. Alright, so now we have east here. Alright, that tells you in which hemisphere we're going to be in our east-western. Alright, so we have north, we have east, so we know it's going to be in this quadrant. Alright, and then it tells us the angle, which was 45. So we just measure 45 degrees this way, and that will give you our bearing. Okay? Alright, so the other way that we do this is called azimuth. Alright, so azimuth is simply degrees from north. Alright, and that's just going to be measuring all the way around the circle. Alright, whereas in quadrant we just measure from north up to 90. Now we're setting north to 0 degrees. Alright, and measuring all the way around. Alright, so if we set north to 0 degrees, then east is 90 degrees off that, south is another 90 off that, which puts that at 180. Alright, and then which is another 90, 270, all the way back up to 360. Alright, so how do we represent that? Alright, well, it's simpler, where we just take our protractor or our compass and we just measure all the way around. So let's say we have it going off this, no, going off in this direction. All right. Easiest way to do that, just measure all the way around. All right. So that is, I'm gonna say 250 degrees. Just eyeball on that. All right. So now, how will we record that in azimuth? Well, if you remember in quadrant, we had this 2-value system. All right, where it's always 2 values in the middle. Azimuth, on the other hand, is always 3. Okay, so in this case, we just write 250. All right, but in this case, where we have our north 45 east, we just have 45 degrees off north. We need to write it as 045. All right, so in this system, they can be converted between each other. Okay. For your lab, everything's going to be in azimuth, but you'll need to know how to convert quadrant to azimuth. All right. So, easiest way to do that is just think about it. Where on the, and which direction do you need to go to get back to 360, essentially. All right. That didn't make sense, but simply, you have your protractor. All right. If you have, let's say, south 10 here, south 10 west. All right. Well, we know south is 180. We know it's going to be adding, so we just take 180 plus 10. All right. Then if we have 280, all right, so this is going to be north, what's that, north 80 west. All right, well, we know that it's just 10 degrees off our west. We know west is 270, so we just take, since we're still going up, we're just going 270 plus 10. All right, and that works all the way around. As long as you know your reference angles, all right, you can just simply add or subtract to figure out how to convert to see how far you've gone. All right, so let's just say you have north 50 west again. Okay, so you've taken this north 50 west line. We know this is 360, so we know it's 50 degrees to the left, so that's 360 minus 50 to give you 310. Okay. All right, so that's all what I've done here. So we defined attitude, all right, where we have a direction and we have an angle of tilt. All right, well, now we're going to take that and apply that to sedimentary rocks. So when we're talking about sedimentary rocks, we're going to be measuring the strike and dip. All right, so that's going to be specifically for dipping beds. All right, so what are strike and dip? Well, strike is any horizontal line on a dipping bed. Simple enough. All right, where we take a dipping bed like we have in our manual here, that's going off down like that, and we take a horizontal and we cut it across right there. All right, so if we take that strike and we take a compass and we measure that direction, that will give you the strike direction. All right, and we write that in azimuth. All right, then we apply what's called the right hand rule. Okay, so right hand rule is just going to be a way that you can orient your strike versus your dip. Okay, so by definition, strike and dip or dip direction are 90 degrees from each other. They are perpendicular. Okay, but we don't know if our strike, if we were to look at our compass here, is going, if we have a straight line going like this, we don't know if it's going north or south, and that's where we need to apply the right hand rule. Okay, so in this case, we're going to stand on our strike, all right, legs straddling the strike, all right, and we're going to point our right hand down the dip. All right, which means whichever way that dip is going off in, which direction is it tilting, okay? And then whichever direction is going forward, all right, that's going to be your strike direction, all right? And that's how you're going to measure that, okay? So if we have a straight line here as our strike, but it's dipping that way, then we're going to measure off in this way to the south. Okay, so that's strike. All right, so now dip is just going to be how far down from horizontal has it been tilted. Okay, so if this is originally like this, all right, and then you tilt it like that, dip is this angle here. Simple enough stuff. Okay, so now what does that look like if we were to take this all back and look at our geologic map? All right, so you pull up your map, you're going to see symbols like this. All right, so what this is telling you the strike, the dip direction, and the dip angle. Okay, so this is where you need to apply your dip direction. Your right hand rule, my bad. All right, so we have this line here, this long one. That's going to be your strike line. All right, that is going to be going off. That's going to be measured with a protractor going off in the strike's bearing. Okay, so if I were to take my protractor here, okay, and measure which way that's going, that will give me my strike. Okay, so then we know that it is dipping to the southeast, or at least down to the right in this case, and it's 33 degrees. So what that's saying is that if we take our horizontal, here's our dipping bed, all right, this angle here, right here, is 33 degrees. All right, and so we have all these different symbols here. All right, but this is going to be your most common one. All right, this is going to what you're going to be using the most. Okay, so here's some practice in your lab manual. That about covers it for part 1. Part 2 will be out shortly. I'll put a link in the description when I get done, and we're going to discuss what some of this stuff means. You know, what kind of patterns can we find, what's happening to the rocks, and what does the strike and dip tell you about the geometry and the orientation of these rocks. All right, so that'd be it.